this is Janvi Sharma and this is the another video of 5th semester paper. This is the internal 2 question paper solution. So question number 1 says that algorithm for decision tree induction. So in previous video we are discussed some basic knowledge of decision tree and the question that is based upon decision tree. So in this video we are discussing the algorithm for decision tree induction. So let's moving towards the solution. So decision tree induction is a supervised learning method that is used in data mining for classification and regression method. So it is basically used in data mining for classification and the regression methods. It is a tree that help us for decision making purposes. So basically it is a tree that is help us for making the decisions. The decision tree creates the classifications or the regression model as a tree structures. So the algorithm says that there are several steps. So there are basically total 5 steps that we are discussing. That is step 1. So begin the tree with the root node says as which contains the complete database. So it start with the root node. So first step mein we are basically defining the root node. Now in second step, find the best attribute in the data set using attribute selection measure, that is also called as ASM. Now in step 3, divide the S into the subset that contain the possible values for the best attribute. So in this step we divide the S into the subset that contains the possible values for the best attributes. Now in step 4 we have to generate a decision tree node. So in this step we have to generate decision tree node which contains the best attributes. And in last step, recursively make a new decision tree using the subsets of data set created in this step 3 to continue this process until the stage is reached where you cannot further classify the nodes and call the final node as a leaf node. So decision tree use multiple algorithms. Here we can say that the decision tree use multiple algorithms and decide to split a node into 2 or more subnodes. The algorithm selection is also based on the type of target variables. Now let us look upon the some other algorithms that is used in decision tree. So there are some other algorithms that are used in decision tree, that is IDE3, that is extension of D3, that builds the decision tree using a top-down greedy search approach. Now the another is C4.5, that is successor of IDE3. Third is CRT, that is classification and regression T, and that is CHAID, that is Chase square automatic integration decision perform multi-level splits when computing classification of tree, and that is MARS, that is Mars for multivariable adaptive regression splines. Now moving towards our another question, that is question number 2. Question number 2 says that what is the attribute selection measures? Explain 3 of them. Here we have to classify the attribute selection measures. So our answer is attribute selection measures are also known as the feature of selection criteria or the split criteria that are used in decision tree algorithms to determine the best attribute to split the data at each node. So we have to explain the 3 of them. So there are the first method, that is random selection. In first method we have the first method, that is not a good method. It can lead to inaccuracy and may give wrong results. That's why it's not preferred to use this method. So this method is a random selection. So basically it is not a good method. Second method is method 2, that is using the information gain. Information gain is based upon the concept of entropy from information theory. Entropy measures the uncertainty or disorder in a set of example. Information gain is a reduction in entropy or gain in information by selecting a particular attribute or a splitting node. Node with the lowest entropy and more information gain is selected as a splitting attribute. Method 3, using Gini index. So Gini index is a measure of impurity. It represents the probability of incorrectly classifying an instance in the dataset. A lower gene index indicates a purer dataset. Lower gene impurity indicates the purer node. That node is selected as a splitting attributes. Now moving towards the last question, that is question number 3. Define and write the mathematical expression for information gain, gene index, reduction in impurity. So here we have to write the mathematical expressions of the following terms, that is information gain, gene index and reduction in impurity. So let's looking towards our solution. So first we have the mathematical expression of information gain. So the definition of information gain is: information gain is a measure that is used to decide the order in which attributes are tested in a decision tree. It qualifies how well a particular attribute separates the data into the classes. Here is the mathematical expression of information gain. So we have the mathematical expression of information gain. So this is the highlighted part is the mathematical expression of information gain. Now gene index. So the definition of gene index says that gene index is the another metric that is used to evaluating splits in a decision tree. It measures the impurity or disorder of a set of data points. A lower gene index indicates more pure nodes. So now looking towards the mathematical expression. So this is the mathematical expression that is highlighted. So this is the mathematical expression of gene index. So in this, where the C is the number of classes and the probability of the classes I is the proportion of the data points that is in the node that belongs to class I. So third terminology, that is reduction in impurities. So the definition of reduction in impurities says that in the context of decision trees, the reduction in impurities measure how much the impurity decreases after a particular split. It is used to assess the effectiveness of a split. Common impurity measures include, now there are some measures that includes: first is gene impurity, second is entropy, and third is classification error. So gene impurity is a lower gene impurity that indicates a purer nodes, as we discussed further. So entropy, lower entropy signifies more organized pure node. Classification error, like gene impurity, lower classification error indicates a purer node. The reduction of impurity uses criteria selecting the best split of each nodes during the building process. So this is the mathematical expression. This is the mathematical expression of reduction in impurity. Now question number 4. Explain the concept of overfitting and tree pruning. So here we have to explain the concept or the definition of overfitting and tree pruning. So what is overfitting? Overfitting is a common problem that needs to handle while the training of the tree model. Overfitting occurs due to when the model fits too closely to the training data that may become less accurate when encountering the new data or predicting future outcomes. In an overfit condition, a model memorizes the noise of a training data and fails to capture the essential patterns. Key characteristics. So here are some key characteristics that include high training accuracy, low test accuracy, complex models, memorization, and tree pruning. So first is high training accuracy and low test accuracy. In this model that may achieve very high accuracy on the training data by perform poorly on a nuance in data. Second is complex model. So complex model overfitting often occurs when the model is used complex capturing noise and the training data. Third is memorization. So the model may memorize the training data instead of learning the general patterns. And tree pruning. So tree pruning is a technique that is used in a decision tree algorithm, including those for the classification and for also the regression. Decision tree have the tendency to grow excessively deep, capturing noise in the training data and leading to overfitting. Pruning is a process of removing parts of the tree that do not provide the significant predictive power, thus simplifying the model of improving its ability to generalize. So here are the unpruned decision tree and a pruned decision tree. So here are two decision tree, that is first an unpruned decision tree, that is this one, and a pruned decision tree, that is this one. Now there are two main types of